Right, good morning. Can you hear me? Can you hear me?
Yes, sir.
Okay. Yesterday we stopped here. Today we will do the forward pass calculations and backward pass calculations for this project network. If you remember the activities and predecessors, right? The activity A predecessor is none, right? And no predecessors for activity A. Then B, C, and D. If you take A, B, C, and D, the predecessor is A, right? Then you can start B, C, and D from activity A. You should show the arrowhead also. In some cases, we have seen, right, when we are doing paper marking, right, the arrowhead is missing. Just they are putting a line. It's wrong, right? Then you should put the arrowhead also to show an activity. Then activity E predecessors are B and C. Then we have to combine B and C. To combine B and C, we can use a dummy activity. The duration of the dummy activity is 0, right? E activity E. Activity F predecessors are B, C, and D. Already we have combined B and C, then you can combine D also. When it comes to this point, right, we have combined B, C as well as the D. Then you can start activity F. Then activity G predecessor is F. Then activity H predecessors are E and G. Then you can simply combine E and G and start activity H. H is the last activity of the project. Then, sorry, you can put the duration of those activities. Activity A duration is 5 days, B 15, C 10, D 5, E 15, F 10, G 170, H 35. Am I correct? These figures are correct? හරිද මේ figures?
Sorry, sir.
Right? Then you have to divide these events into 3 parts. Keep in mind the event should be numbered, right? If you have activity on arrow diagram in the exam, right, the marks will be allocated for the numbering of events also, right? 1, 2, 3, 4, 5, 6, 7, 8. What is the rule of numbering events? The head event number should be greater than the tail event number. All the times our head event number should be greater than the tail event number, right? දැන් මතක තියාගන්න ඊතලයේ හිස පැත්තේ තියෙන අංකය හැමතිස්සෙම වලිගයේ ප්‍රස තියෙන ඉවෙන්ට් අංකයට වඩා වැඩි වෙන්න ඕන. ඒක තමයි රූල් එක නම්බරින් එක, right? Then we can start the forward pass calculations. Then we will start from the left hand side of the project network diagram. As you know, the early start time of the first activity is 0. 0 plus 5 5, right? Then activity B, duration is 15, 5 plus 15, 20, right? When it comes to event number 4, we have two paths, right? From event number 3 and from event number 2. එතකොට 20ට බිඳුවක් එකතු කරාම 20යි, 5ට 10ක් එකතු කරාම 15යි. And when you are doing the forward pass calculations, if it is a merge thing, we will take the maximum value. Maximum is 20. When it comes to the event number 5, you have two parts, then 20 plus 0, 20, 5 plus 5, 10. The maximum is 20. Then F, 20 plus 10, 30. When it comes to the event number 7, we have two parts, 20 plus 15, 35. 30 plus 170, 200. Maximum is 200. Then 200 plus 35 to 35, right? Then you can do the backward pass calculations. The backward pass calculation will be started from the right hand side of the network diagram. Right? Then late finish time of the last activity equals to the early finish time of the last activity if we do not have any imposed date. Therefore, 235 is the late finish time of activity H. Then 235 minus 35, 200, right? දැන් ඔයගොල්ලන් පේනවා ඇති forward pass calculations වලදී අපි duration එක එකතු කරා, backward pass calculations වලදී අපි මොකද කරන්නේ, duration එක අඩු කරගෙන එනවා, right? When you are doing the backward pass calculations, you have to be careful with the burst activities. Then G, 200 plus minus 170, 30. Then F, event number 5, 30 minus 10, 20. When it comes to the event number 4, you can see there are two paths, right? Then 20 minus 0, 20. 200 minus 15, 185. The minimum is 20, right? Then at event number 3, 20 minus 0, 20. Event number 2, 3 backward paths, 20 minus 15, 5, 20 minus 10, 10, 20 minus 5, 15, minimum is 5. As you remember, when you are doing the backward pass calculations, we take the minimum values, right? 5 minus 5, 0. Then you have to identify the critical path. Can you identify the critical path? Can by critical path what is the critical path? A, B, dummy, dummy 1, dummy 2, then F, G, and H, right? The critical path is A, B, F, G, and H. Expected time of the project is 235 days or weeks, right? Then what are the critical activities? The critical activities are A, B, F, G, and H. Non-critical activities. What are the non-critical activities? C, D, and E. Right? C, D, and E are non-critical activities. Then you can find out early start time, early finish time, late start, late finish, and total slack of these activities, right? Shall we do that? Activity A, B, C, D, E, F, G, and H. Then you can put the duration 5, 15, 10, 5, 15, 10, 170 and 35. You can find out the early start, early finish, late start, late finish and total slack. Right, if you want to find out the early start time of an activity by using activity on arrow diagrams, right, look at the tail event. What is the tail event of activity A? Can you tell me the event number? Tail event number of activity A?
1.
1. Right, then look at the left hand side value. What is the left hand side value? 0. It represents early start time of that activity, right? If you know the early start time, you can simply find out the early finish time. Early finish time equals early start time plus duration. The duration is available in the second column, right? We found the early start time, then add duration to the early start time, you can find out early finish time. Fine. Activity B, right? Look at the activity B, tail event. What is the tail event number of activity B? B के tail event number එක මොකක්ද? 2. Then the left hand side value 5. Then early start time is 5. 5 plus 15, 20. Activity C, right? The tail event is event number 2. Left hand side value is 5. 10 plus 5, 15. Right? Activity D, tail event is number 2. Left hand side value is 5. 5 plus 5, 10. Right? Then activity E. Activity E, what is the tail event? The activity E tail event is event number 4. Left hand side value is 20. 20 plus 30, sorry, 20 plus 15, 35. Activity F, tail event is event number 5. Left hand side value is 20. 20 plus 10, 30. Activity G, tail event is number 6. Left hand side value is 30. 30 plus 1, 70, 200. Right, activity H, tail event is 7, number 7. Left hand side value is 200. 200 plus 35, 235. Then we will find out the late finish time of all the activities, right? Then if you want to find out the late finish time of an activity, look at the head event of that activity, right? The head event of activity A is 2. Then look at the right hand side value. The right hand side value is 5, right? Late finish time. If you know the late finish time, you can simply find out the late start time. Late start time equals late finish time minus duration. Right, late finish time is 5, duration is 5, then late start time is 0. Right? Activity B, what is the head event? Head event number is 3. Right hand side value is 20. 20 minus 15, 5. Activity C, tail event is event number 4. Right hand side value is 20. 20 minus 10, 10. Activity D, tail event is event number 5. Right hand side value is 20. 20 minus 5, 15. Activity E, head event number is 7. The right hand side value is 200. Right. If you want to find out the late finish time, look at the head event and right hand side value. 200 minus 15, 185. Activity F, head event is event number 6. right hand side value is 30, 30 minus 10, 20. Activity G head event is 7, right hand side value is 200, duration is 170, therefore late start time is 30. Activity G head event is event number 8, right hand side value is 235, 235 minus 35, 200, right? Then you have to find out the total slack. The total slack equals late start time minus early start time, right? We have already found the early start as well as the late start. Simply take the difference. Activity A, late start time is 0, early start is 0, the total slack is 0. Activity B, 5 and 5, 0. Activity C, 10 and 5, difference is 5. Activity D, 15 and 5, difference is 10. Activity E, 185 and 20, the difference is 165. Activity F, 20 and 20, 0. Activity G, 30 and 30, 0. Activity H, sorry, 200 and 200, 0. Right? Then we found the critical activities A, B, right, F, G and H. Look at the total slack of these activities, right? The total slack of critical activities are zeros, right? The non-critical activities are having some positive slacks, right? What is the meaning of these total slacks? We can delay activities C by 5 days, D by 10 days, E by 165 days without affecting to the expected time duration of the project 235. It's clear? ඔක පැහැදිලිද? ඔයාලට පැහැදිලිද? Anything you want to clarify? මොන හරි තියෙනවා නම් අහන්න. දැන් අපි මේ කරපු ටෙක්නික් එකට කියනවා අපි මොකක් කියලාද? Critical path method, CPM, right? The CPM is a project management technique, right? Right. We will use critical path method to identify, right? To identify what? මොනවද මේ CP එකෙන් identify කරන්න පුළුවන්? We can identify the sequences as well as the dependencies of activities, right? And we can find out or determine overall project duration, right? Then the CPM helps planning, scheduling, and controlling complex projects, right? The critical path method developed in 1950s by Morgan R. Walker and James E. Kelly, right? In a critical path method, we will use one time duration, right? if you look at this example, all the activities have one time duration, right? Activity A has one time duration, for an example, 5 days. Activity B has one time duration, 15, right? Activity C has one time durations. When we are doing the critical path method, we will have only one time duration for each and every activity. Then we will talk about the PERT method, right? The program evaluation and review technique. In that technique is also a project management techniques, right? In project PERT method, we will use three time durations for a activity, right? Optimistic, pessimistic, and most likely time for each and every activity, right? Did you understand the difference? පැහැදිලිද? දැන් CPM එකේදී අපි හැම ඇක්ටිවිටි එකකටම ගන්න එක ටයිම් ඩියුරේෂන් එකයි. රයිට් දැන් මේ CPM එක කියන්නේ ක්‍රිටිකල් පාත් මෙතඩ් කියන්නේ මේක ප්‍රොජෙක්ට් මැනේජ්මන්ට් ටෙක්නික් එකක්. ඒකෙදී අපිට අයිඩෙන්ටිෆයි කරන්න පුළුවන් සීක්වන්සස් කෝඩ් එක අයිඩෙන්ටිෆයි කරන්න පුළුවන් ඩිපෙන්ඩන්සිස් අයිඩෙන්ටිෆයි කරන්න පුළුවන්. රයිට් දැන් ඔගොල්ලන්ට කිව්වා සිව්වාකාර ඩිපෙන්ඩන්සිස් තියෙනවා. Finish to start, right? Start to start, finish to finish, and start to finish, right? But we are discussing finish to start type dependencies. කිසියම් කාර්යයක් අවසන් වුණාට පස්සේ ඊළඟ කාර්ය ආරම්භ කළ යුතුයි කියන dependency එක තමයි අපි සාකච්ඡා කරන්නේ. ඊට අමතරව තව dependencies ආකාර තුනක් තියෙනවා. right? දැන් CPM එකේදී පුළුවන් මේ dependencies සහ sequences අඳුනා ගන්න. ඊට අමතරව අපිට overall project duration එක දැන් මේකෙදී අපි අඳුනාගත්ත overall project duration එක 235යි කියලා. හරි. දැන් මේක develop වෙන්නේ 1950 ගණන් වලදී right Morgan R. Walker සහ James E. Kelly කියන පුද්ගලයන් විසින් තමයි මේ critical path method එක develop කරන්නේ. right ඊළඟට අපි සාකච්ඡා කරනවා PERT කියලා ටෙක්නික් එකක්. ඒකත් project management ටෙක්නික් එකක්. ඒකෙදිත් අපිට පුළුවන් ඔය කියන sequences dependencies අඳුනා ගන්න. right ඒකෙදි අපි කාල පරිච්ඡේදයන් තුනක් ගැන සාකච්ඡා කරනවා හැම කාර්යයක් සඳහාම. අපි activity A කියලා ගත්තොත් ඒ කියන කාර්යයට අපි durations තුනක් හඳුනා ගන්නවා. pessimistic, optimistic සහ most likely time කියලා. සිදුවිය හැකි වෙනස් වීම පදනම්ව අපි මේ කාල පරිච්ඡේදයන් හඳුනා ගන්නවා. ඒ අනුව තමයි අපි expected time එක හොයාගන්න මේ එක් කාර්ය සඳහා. නැත්නම් weighted average time එක ගණනය කරනවා. right ඔගොල්ලෝ PERT ඉගෙනගෙන තියනවද OR වලට? Have you learned PERT in operations research? Yes or no? Right. Then it's easy. Program evaluation and review technique. Right. Then the PERT assumes each activity durations follows a probability distribution instead of being a single value. right මම ඉස්සෙල්ලා කිව්වා වගේ දැන් PERT එකේදී assume කරන ඒගොල්ලෝ උපකල්පනය කරනවා මේ කාලය සඳහා තියෙන්නේ probability distribution එකක් කියලා. critical path එකේදී අපි ගත්තේ single value එකක්. right then the PERT uses three time estimates. Time estimates for each activity, as I said, optimistic, pessimistic, and most likely time to represent activity durations. We will find out three time estimates, right? Optimistic, what do you mean by the optimistic time? Right? It is represented by A, right? The minimum possible time required to complete an activity, right? If we take an activity for an example A, what will be the minimum possible time required to complete this activity? It is called as optimistic time. We assume everything proceed better than expected, right? For an example, say the weather is good, no strikes, right? Currency rates are good, macroeconomic conditions are good, right? It is better than the expected situation. If we have that kind of situation, right, we will be able to finish that activity as soon as possible, right? Or what will be the minimum possible time to require to complete this activity? It is called as optimistic time, assuming all the things are going in a good way, right? Then the pessimistic time, that is the opposite of the optimistic time, right? What will be the maximum possible time required to complete an activity? For an example, if the optimistic time of an activity A is 15 days, right, we can complete activity A by 15 days. That is the minimum possible time required to complete this an activity if everything proceeds better than the expected. Then we will look at the opposite side of the optimistic time, that is pessimistic time. What will be the maximum possible time required to complete this activity? For an example, say 20 days, right? Assuming everything goes wrong, right? The weather conditions are not so good, the macroeconomic conditions are not good as expected, right? Then this will be the maximum possible time to complete this activity. It is called as pessimistic time. Then you have to find out the most likely time in between the optimistic and pessimistic time, right? The best estimate of the time required to complete an activity, assuming everything proceed as normal. If everything proceed as normal, then we will find out the most likely time, right? Say 17 days, right? Then the optimistic time represented by A, pessimistic time represented by B, most likely time represented by N, right? Each and every activity has three time durations. Based on these optimistic, pessimistic, and most likely time, we can find out the weighted average activity time, right? The weighted average activity time is computed by the following formula. We are using a formula to find out the weighted average activity time. TE equals A plus 4M plus B divided by 6, right? A is the optimistic time, B is the pessimistic time, M is the most likely time, right? Then why it has been divided by 6, right? If you look at A is a variable. What do you mean by the variable? The values can be changed, right? What is the coefficient of A? A වල coefficient එක කීයද සංගුණකය? ඒගේ ඉස්සරහින් කීයක් තියනවද? අපි ලිව්වේ නැති උනාට. මෙතන තියෙනවා the coefficient of A is 1, right? In this formula, to A or to the optimistic time, the weight given is 1, right? Then the most likely time, right? What is the coefficient of M? Coefficient කීයද? M වල. නැත්නම් සංගුණකය. M වල සංගුණකය කීයද? M
4.
වල ඉස්සරහින් තියෙනවා 4ක්, right? Then the weight given for the most likely time is 4. B, what is the coefficient of B? Even though we haven't written the coefficient in front of the B, it is 1, right? එතකොට B වලට දීලා තියෙන weight එක එකයි. Right? Then if you get the summation of the weights or the total weights is 1 plus 4 plus 1 equals to 6. If you want to get the average, right, the value should be divided by 6. That's why the formula, the upper part has been divided by 6. Right? Keep in mind the formula. The weighted average activity time equals A plus 4M plus B divided by 6. Right? Then you can find out the standard deviation of an activity. Right? The variability in the activity time. Right? Or variability or uncertainty in the duration of the activity can be measured by using standard deviation. Right? The variability in the activity time is approximated by the following equation. Right? Keep in mind how to find out the standard deviation for the activity. Right? By using the previous formula, we can calculate the weighted average activity time or the expected time of an activity. Now, if you remember, for each and every activity, we are using 3 time durations: A, M, and B, optimistic, most likely, and pessimistic time. Then we have to find out the variability or the uncertainty in the duration of these activities. Right? For that, we are calculating standard deviation. පැහැදිලිද? දැන් අපි PERT එකේදී මේ කියන ආකාරයෙන් කාල තුනක් කතා කරනවානේ, ඔප්ටිමිස්ටික්, පැසිමිස්ටික් සහ most likely කියලා. ඒක පදනම් කරගෙන අපි හදා ගන්නවා මොකද්ද? බරිත සාමාන්‍ය කාල පරිච්ඡේදය. right? දැන් අපි ගත්තොත් මේ normal time එක හරි expected time එක හරි දැන් මෙතන තියෙනනේ අපි අපේ අන්තිම calculation එකත් එක්ක කාල පරිච්ඡේද 4ක් තියෙනවා. right? හැම activity එකකටම තියෙන කාල පරිච්ඡේද 3ක්. ඒක පදනම් කරගෙන අපි expected time එකකුත් හැදුවා. දැන් ඊට පස්සේ බලනවා මේ activity වල මේ duration වල මොකක් හරි variability එකක් තියෙනවද? right? දැන් අපි හිතමු optimistic time එක 2යි, most likely 2යි, ඊට අමතරව pessimistic time එක 2යි. එතකොට මේකේ variability එකක් තියෙනවද? ඔයගොල්ලන්ට පේනවද variability එක? එහෙම standard deviation එකක් නැහැ. right? දැන් මම මෙහෙම එකක් ගත්තොත් දැන් මේ කාල සීමා තුනේ පොඩි අවිනිශ්චිතභාවයක් තියෙනවා. පැහැදිලිද? ඔප්ටිමිස්ටික් ටයිම් එක 2යි, මිනිමම් ටයිම් එක 2යි. right? pessimistic time එක maximum time එක 13ක් වෙන්න පුළුවන්. right? most likely time එක දීලා තියෙන්නේ 5ක්. එතකොට මෙතන variation එකක් දකින්න පුළුවන්, uncertainty එකක්. ඒ හින්දා අපි බලනවා හැම activity එකම මොන වගේ variability එකක් තියෙනවද නැත්නම් මොන වගේ uncertainty එකක් තියෙනවද කියලා. right? Then the standard deviation of an activity equals B minus A divided by 6. Right? If you want to find out the variation of an activity, what I have to do, B minus A divided by 6, then get the square value. If you get the square value of the standard deviation, you will end up with the variation. පැහැදිලිද? දැන් සම්මත අපගමනේ වර්ගය ගත්තාම එතනින් ලැබෙන්නේ මොකද්ද? variation. right? විචලනය. පැහැදිලිද ඔයගලන්ට? අපැහැදිලි නම් කියන්න. right? Based on these values, you can calculate standard deviation for the project. right? දැන් මෙතන කතා කරේ standard deviation for the activity. දැන් ඊළඟ formula එකෙන් කතා කරන්නේ මොකද්ද? standard deviation of the project. දැන් මුළු කාලයේ අපේක්ෂිත කාලයේ සම්මත අපගමනය. ව්‍යාපෘතියේ මුළු කාලයේ සම්මත අපගමනය. හරි. එතකොට මුළු ප්‍රොජෙක්ට් එකේ මොන වගේ variability එකක් තියෙද uncertainty එකක් තියෙද කියලා තමයි මේ ඊළඟ ෆෝමියුලා එකෙන් බලන්නේ. right. Then the standard deviation of the project equals square root of sigma මේ මොකද්ද කියන්නේ? මෙතනින් හඳුනාගන්න මොකද්ද මේ? මෙතන තියෙන්නේ මොකද්ද? මේ තියෙන්නේ variance of an activity. දැන් මෙතන තියෙන්නේ variance of an activity. එතකොට කියනවා මේ කිසියම් වූ කාර්යයන් සමූහයක විචලනයේ එකතුවේ වර්ගමූලය ගත්තම අපිට එනවලු ව්‍යාපෘතියේ සම්මත අපගමනය. මතක තියාගන්න ව්‍යාපෘතිය සම්මත අපගමනය හොයද්දී අපි විචලනය ගන්නේ critical activities වල විචලනය පමණයි. පැහැදිලිද? Read this sentence carefully. Note the standard deviation of the activity is squared in this equation. දැන් මෙතන පේනවා ඇති standard deviation එක square කරලා තියෙනවා. This is also called variance. දැන් එතකොට ඒකට අපි කියනවා දැන් මෙතන තිබුණේ ZTE එතකොට තිබුණේ standard deviation ඒක වර්ග කරාම අපිට මොකද variance එක. right. This sum includes only activities on the critical paths or plan being reviewed. දැන් ව්‍යාපෘතියේ සම්මත අපගමනය හොයද්දී විචලනය ගන්නේ critical path එකේ තියෙන activities වල පමණයි. පැහැදිලිද? හරි. දැන් මම උදාහරණයක් කිව්වොත් දැන් හිතන්න මේකමයි තිබුණේ මේක ඇන්දේ අපි PERT එකෙන් කියලා. හරි. එතකොට මේ ව්‍යාපෘතියේ ස්ටෑන්ඩඩ් ඩීවියේෂන් එක ගන්න ඕන නම් අපි ගන්නේ A වල විචලනය එකතු කිරීම B වල විචලනය එකතු කිරීම G F G and H ඒ කියන කාර්යයන් පහ. මේ මොකද්ද? මේ තියෙන්නේ critical path activities. මෙන්න මේ time duration වල විචලනයන්ගේ එකතුවේ වර්ගමූලය අරගෙන තමයි අපි ව්‍යාපෘතිය සම්මත අපගමනය කරණය කරන්නේ. නමුත් මේ ව්‍යාපෘතිය ගත්තොත් ඔයාලට පේනවා ඇති C D සහ E non critical. ඒවත් විචලනය හොයන්න පුළුවන්. මේක PERT අනුව තියුණා මේකේ බැහැ PERT හදන්න. හේතුව මේකේ තියෙන එක time duration එක. මම නිකන් පෙන්න ගන්න උවමනා තුනේ critical සහ non critical විතරයි. right. එතකොට විචලනය හොයද්දී අපි ගන්නේ ව්‍යාපෘතිය සම්මත අපගමනය ගණනය කිරීම සඳහා අපි යොදාගන්නේ critical path එකේ critical activities වල විචලනයන්ගේ එකතුවේ වර්ගමූලය. පැහැදිලිද? Is it clear? Yes or no?
Yes.
Right. Right. Try to find out the expected time or the weighted average time, the standard deviation of an activity and variance of each and every activity. හදන්න බලන්න මේ ඒව weighted average time එකයි standard deviation එකයි variance එකයි හැම activity එකටම අදාළව විනාඩි 5ක් අරගෙන හදන්න. What is the formula to calculate the weighted average activity time? A plus 4m plus b divided by 6. Standard deviation of an activity equals b minus a divided by 6. The variance of an activity equals b minus a divided by 6, then get the square value. Then 6යි b මාරු කරගන්න එපා. මේ තියෙන්නේ b, උඩ තියෙන්නේ b, යට තියෙන්නේ 6. right, a කියන activity එක ගත්තොත් a වලාගේ 8යි 4m 4යි වරක් 10 එකතු කිරීම 16 බෙදීම 6. 64 බෙදීම 6 කීයද? 10.67. Am I correct? හරිද අගය?
හරි සර්.
Then standard deviation. ඒතර b වලාගේ 16යි a වලාගේ 8යි බෙදීම 6. standard deviation එක එනවා 8 බෙදීම 6. 1.333. එතකොට variance එක එනවා 16 අඩු කිරීම 8 බෙදීම 6 වර්ගය 1.33 වර්ගය. ඒතකොට එනවා අපිට 1.78ක්. ඒ වගේ ඉතුරු ටිකට කරන්න බෑ. If you finish, let me know. Activity B, what is the weighted average time? 12.17. Haridhar,
Sorry, sir.
0.5 and 0.25. Correct? 12.33. Check my answers, right? Right, check your answers. I got these values. What about your answers? You got the same answers? මේ උත්තරම දාවේ? 66.47. ඊළඟ දවසේ අංකෙත් එක්ක නම නමත් එක්ක රීනේම් කරගෙන ඉන්න. ඔයගලගේ MF එකේ අංකෙත් අමතරව නම තියෙන්න ඕන. පාවිච්චි කරන සර්නේම් එක දාන්න එපා. සමහර අය දාලා තියෙන්නේ තිලංක තියෙනවා, කලණි තියෙනවා. ඒ වගේ නමත් එක්ක අංකේ තියෙන්න ඕන රීනේම් කරගෙන. තමන්ට මතකත් නැහැ සමහරලාට අංකෙන් ඇහුවට. හරි. දැන් ඊළඟ දවසේ ඉඳන් අහන ප්‍රශ්න වලට වැරදි උත්තරයක් හරි කියන්න ඕන. හරි නැත්නම් මම කරන්නේ රිමූව් කළා දාන්න. මතක ඇතුව හැමෝම රීනේම් වෙන්න ඕන නම සහ අංකය ඇතුළත්ව සර්නේම් එකෙන් රීනේම් කරන්න එපා. තමන් භාවිතා කරන නම තියෙන්න ඕන. right. දැන් මේක නිකන් ගොළු ටිකකට උගන්වනවා වගේනේ. උත්තරේ හරිද කියලා ඇහුවත් නැහැ. එක ළමෙක් විතරක් හරි දෙන්නෙක් විතරයි උත්තරයක් කියන්නේ. තේරෙනවද නැද්ද කියලා ඇහුවොත් ඒකටත් උත්තරයක්. Right, we will stop for today.